And next up, we have Natalie. She will be sharing her insights in enhancing your Flutter code base with the Analyzer package. Stage is yours, Natalie.
To this talk, today I will be going over how we can streamline quality checks by leveraging custom lint rules. So in today's agenda, I will give a brief introduction about myself and background and set the stage for understanding custom lints and static code analysis. Then we will dive into how we can write custom lint rules using two approaches. The first will be how we can do that with using the Analyzer package, and then we will see how we can do with using the custom lints package. And finally, we will provide a brief analysis of both approaches and discuss the pros and cons. So a bit about myself. I started my developer journey around 2 years ago, and initially my role was a full-stack web developer. And I've had multiple languages that I was exposed to. During my studies, I was mainly working with Python, and then in my first role, I worked a lot with Angular and React. And around 7 months ago, I transitioned into being a mobile developer. So my main language I work with now is Flutter and Dart. And one thing I noticed having exposure to all of these languages is that a lot of the times I find it a little bit debilitating thinking of the correct syntax to implement simple things, really. So a lot of the times I feel like this. And one thing that really helped me joining a new team was that they have already set some custom lints, and that really helped my learning process initially because I was made aware of all the syntax violations and code practices that team follows. So a little bit more about lints. What is a linter? Linter is a program that we run to analyze code. And this originated from a Unix utility that examined C language source code. The name was inspired by the bits of fiber and fluff shed by clothing. So a linter acts as a lint trap, catching all problematic code while leaving the rest intact. So it analyzes any errors, style code violations, and just overall ensures consistency throughout the code base. But what if we have specific needs that are not covered by the standardized linter? You may be already using the Flutter lints package, which is built on the core set of rules in Lint. Now, all of these rules can be enabled through the analysis options file, and you can set which rules you want to exclude and which files you want to suppress, for example. And a lot of code bases already use the standardized linter. You can run this standardized linter by simply running the Dart analyze command in your command line interface. But what if there are project-specific needs that are not covered by this linter? In this case, custom lints come in really handy. So when we have project-specific requirements not covered by the linter, we have the option to create our own custom lints. And there are two approaches to doing so. The first one will be creating your own custom lint plugin that leverages the Analyzer package. And the other one will be using the custom lint package, which is actually also built on top of the Analyzer package. So I've mentioned Analyzer package a lot. Let's have a little bit more background information about this Analyzer package. So this Analyzer package is a very powerful tool for static code analysis and examines the code without executing it to identify potential errors and help adhere to coding standards. This package is not only limited to analyzing syntax, but also provides really insightful code metrics for things such as code duplication, unused code, or systematic complexity. And all of these tools are really helpful, and we can create custom plugins for specific analysis needs. Now, what's really great about this package is that it includes a comprehensive API that can parse, analyze, and transform Dart code in real time, making it a great tool for building custom analysis tools like custom lints. Now, if you're wondering how can we get all this feedback in real time, this is because the analyzer package has a client-server connection with the Dart analysis server. And this provides real-time code analysis. And on top of that, there are built-in debugging interfaces provided by Dart that can help us debug and monitor the Dart analysis server. So let's dive into this analysis server diagnostics tool a bit more. As we can see here in our IDE, we can run the diagnostics server by simply going to Dart and then open Analyzer Diagnostics. So this will be running on a port, on your local port, and will give you a lot of information about your current workspace. So currently I have a sample project loaded in my IDE, and we can already see all the analysis context provided. Now, analysis context is a unit that the Dart analysis server picks up on, which has its own dependencies, and it's usually defined by just a root directory and a file that encapsulates the dependencies. So here we have a plugin, and as we can see here, another custom context analysis is the first package custom lint approach, and then another sample package. What's great about this is we can also assess all the files in this analysis context, and you can assess the abstract syntax tree for each file. So if we delve into this here, we can see this is a very simple file, but we have a main compilation unit and all the child elements. So if you want to examine a different file, that can also be possible. You'll see it will have a much larger abstract syntax tree. On top of that, you can see any information about the plugins. As you can see here, we have a plugin configured, and we will delve into how we can set that up later on. And you can see there's a specific section to get information about the plugins in use. And of course, there's a lot of other sections that can help you with analyzing the memory, the performance, and timing of your utilities. So, as soon as you open your IDE, the Dart analysis server is started and it's initialized. After that, it loads any configured plugins and then creates analysis context for each package. After that, it will scan all the relevant files in the project, and as you develop and add more files or codes, the last two steps will be reiteratively run. So it will create a different analysis context if necessary. And this is the general analyzer lifecycle. So let's dive into the first approach. That is creating your own custom plugin using the analyzer package. So there are some base requirements for this. And of course, initially you need to create the plugin. So for that, we will need to specify whether we want a Dart package or CLI tool. In this demonstration, we will be looking how to create a CLI tool so we can run it from the command line. And then we will specifically focus on how we can configure the pubspec files and bin file for our main package and the sub package that we will create for the plugin. After the setup is done, I will go over also how we can visit and parse the files and apply these custom rules. So in order to create the CLI package, you can run a very simple command on your terminal and create a package, name it however you like. In this case, it will be called IB-lint, and specify the type to be CLI. This command will just provide a simple skeleton for our project, and we will specifically focus on how we can configure the bin and pubspec YAML file. So in order to create the sub package for this plugin, we will have to follow a specific convention. And that is, we have a required folder structure. So in order for the plugin to be loaded into the analyzer. And for this, we need to create a tools directory inside our project and have analyzer plugin directory inside of that, which we will have, again, our own pubspec YAML and bin file. So since this is an encapsulate package with its own dependencies, this will be considered its own analysis context. So if we have a high-level overview of how this structure looks like, we will have the CLI tool package with its own dependencies and executable file. And inside of that, inside the tools analyzer plugin, we will have the sub package with its own, again, dependencies and executable. And both these packages will be sharing a common library. So let's dive in to the first dependencies and bin executable for the main package. In order to configure the main pubspec YAML, you will have to remember just to add the dependencies. So in here, we will have the analyzer and analyzer plugin as dependencies, and we will add lints as dev dependencies here. And of course, here you can also specify the name of your plugin. This will be the same name as your bin executable file. So let's take a look at the bin executable file. This will be a very simple file that is the main function that redirects to the main source code in the library. And this calls the plugin and runs the project. So now let's have a look at our sub package and examine the dependencies and executable files there. So if we take a look at this, remember that this will be located inside of the folder structure we set up, which is under Tools and Analyzer plugin. And in here, the main dependencies we need to add is our own custom lint we create, which is, in this case again, called IB lints. And now let's have a look at the executable file. In here, we will have one main function that will pass the arguments and port and call the start method using the port. Now this send port is actually the port number that facilitates the communication between the Lint plugin and Analyzer server. And we call the start method passing the send port to begin the linting process. So now that we have the main setup for the main package and sub package out of the way, let's take a look at the common library. In order for both of these packages to use the common library, we will have to export certain things. So in this, we have an IB-lints file, which is the name of our plugin in the library. And we will be exporting first the entry point for the plugin, which will be in a file called starter, which we'll examine in the next slide. And the second export will be an entry point for the command line interface. So the plugin starter file will be located in the source directory inside a plugin folder, which will both have the actual plugin and the starter file. So the starter file has a start method called from the plugin directly, and it uses the port which the analyzer runs on. This is the start method that is actually used in the main bin file we went over. And it is required to pass an instance of server plugin starter and call the start method on it. In this instance, we will pass our own custom plugin, IB-lints plugin, which is the other class found in this plugin directory. We simply pass a resource provider, and in this case, it's just a physical instance. and we call the start method on the server plugin starter and pass the port. So all this does is that it helps the plugin be loaded and started. We'll cut this from here, just moving to the next section. Okay. So now that we have the main setup out of the way, let's take a look how we can visit the file, parse the contents, and run the lint rules. So let's take a look at the plugin directory. In the plugin directory, we will find the IB-Lints plugin file that we just passed in the starter. And what we have to set up is and make sure is that this IB-Lints plugin extends server plugin. And the server plugin is an abstract class provided by the analyzer. This setup ensures that we can integrate our plugin with the Dart analysis server. As you can see, we have multiple overrides we need to implement. Let's take a look at these overrides. The first three are quite simple. These are just some boilerplate code to get the name and look at which files to analyze. And then the third override to get the version is just the version number of the protocol used to communicate with the analyzer. Now, if we have a look at the last two overrides, we can see one override called the after new context collection, which is run after a new analysis context is attached to the analyzer. And then the other one override is called the analyze file. And this will be the main logic that will analyze, parse the file, and report the error. So let's have a deeper look at the after new context collection. So as I mentioned, this runs every time a new context is attached, and what it does is that it loops through each analysis context provided in the context collection, and then it just checks the path and file and checks the analysis options provided in this analysis context. So each analysis context will have an analysis options file that we can specify which rules we want to ignore or which files we want to exclude. Having that said, it just checks if the analysis options file exists, and if it does, then it will read the options from the file and update the options map with the path. After that, we will just call the superclass method after new context collection and pass the context collection. Next, let's have a look at the analyze file override. And then we will parse the file into tokens and construct the abstract syntax tree. So as you see here, we are getting a resolved unit for each path. And the unit is very much the root token of the abstract syntax tree. So each file is parsed into an abstract syntax tree, and then all of the abstract syntax trees have a root unit called compilation unit. So then we will have some boilerplate set up for initializing the errors, checking the analysis options, and setting the severities for the errors we want to report. So that can be an error or info level or warning. And this is where the main processing of the visiting the nodes happens. This is where the magic happens, if you want to call it that. So on each compilation unit, we will visit the children, and we will use the visitor to traverse through each of the children in the unit. And in the visitor class, which I will go into more detail into the next slide, we will just be passing the path, the compilation unit, set the severities, and most importantly, apply the rule if the lint is found. So we have some additional logic just to check if there's any suppressions, but if not, we add the error on lint found. And finally, we send the error reported to the analysis server. Now let's take a look at the visitor class. This is what we have used in the previous slide, if you see here. So in the visit children method, we are passing the visitor class. So this is an abstract, this is a class that we have to extend the generalizing abstract syntax tree visitor. So we will create a constructor and pass all of these parameters that will help us specify more information about the error we want to report, the path, and what we do when the lint is found. In this visitor class, as it extends the generalizing abstract syntax tree visitor, there are multiple options for overrides that we can specify the context of when each rule is run. For example, if we want to run a certain rule only when it visits an expression, this is the file where we specify it at. And there's a lot of options, so we can limit the scope for how each rule is run in. So if we take a look further into one of the overrides, you can see all we have to do is have a list of the rules we want to run. In this case, we're just running one rule, and I will go more into detail about how we set up these rules. And we will just pass some boilerplate code about the node, path, compilation unit severities. And if you want to add more than one rule into the method, that is also possible. You will just extend the list. And for all of the rules you add, you will just run for each rule, run the lint. And finally, you run the super method. So now that we had a look how we can visit and parse the contents, let's see how we can create the lint rules and run them. So now that we had a look how we can visit the file, parse the contents, we'll have a deeper look in how we can create our own custom lint rules and run them. So just a little bit more of a setup into writing the lint rules we create. We will create an abstract class inside of the plugin directory, inside the source file. And in this abstract class, we will just pass some parameters we need, such as the node, path, compilation unit severities, and what on the onLint found method. So just to clarify, this is an abstract class that will make creating the rules much simpler and cleaner. And this is the class that we need to extend all the rules we create to. So if we expand this class, what we need as well is that we need a main method, void run, and this abstract run method is what the subclasses will be using, and then also a report lint for method. So let's have a look more about the report lint for, which is run when an error is found. So when it is found, we return an object of type analysis error, where we set the severity of the error found, and then we set the message we want to display when the error is found, and also the code, which is the name of the rule we have run. We can also provide the location of where the error is found. So this is all just some setup to specify the location, specifically where it begins and ends. And finally, we have an additional method called the run lint, which simply takes a lint rule as a parameter and runs it. Okay, now that we went over how we can visit and parse the files, let us dive into how we can add the rules. So all of the rules we will add will be included in this rules directory. And for that, I will give a brief demo how we can write the rules and run them. So in here, you can see I have set up our own custom linter, which will be using the analyzer. This is custom linter approach 1, and a very simple sample project. Now in the sample project, do note that in the PubSpec YAML, we are adding this plugin as a dev dependency, and of course specifying the path so that we can use it in our sample project. So in here, let's first go into our library and open our source code. We see here we have a rules directory, but it's empty. So let's go ahead and start by creating a file. And for this demo, I will just write a very simple rule to avoid force unwrapping. So we can go ahead and name our rule, avoid force unwrapping, .dart. And in here, we will just create our rule, so final class, and name it the same, avoid force unwrapping. And as I mentioned before, we have created an abstract class to help us write any rules we have. So this is the abstract class we went over, called Lint rule, where we set the message, severity, and report the error. So any rule we create, we will have to extend to Lint rule. And of course, let us import it. And inside this, we will have a constructor where we pass all of the necessary parameters. So let us do that. So here, what we will need is all the parameters we set, such as path. And then let me just, for the sake of time, I'll just be copying this. So we have the path, compilation unit, node, severities, and finally, the onLint found. So now we have the main setup ready for the constructor, and we can go ahead and start with adding the override methods. So we can see here there's a quick way to do that. We create our 2 missing overrides, as you can see here. And for this override, this will just be the message displayed when we have an error. So as I mentioned, this rule will be for avoid force unwrapping. And just a little context, if you don't know what that is, this is when you have an object, such as int or whatever, and you are trying to access something from it. A lot of the times, if there is a null check and you want to bypass it, you can just add this bang operator. And what this communicates to your IDE is that this cannot be null. So it's a little bit tricky, because if it is null, then this can cause errors in your code base. So that's why we are writing a rule to just make sure that in your entire code base, null checks are implemented properly and it is not used. So for the message, we can write anything, hopefully something informative. So force unwrapping should be avoided. And in your run method, what we will do is just set the final node to be this .node, so that we can get the node we want to analyze and check. And this is where we implement our logic for the node. So if the node is post this expression, so just post its expression, and the node operator here, if it has type of the exclamation mark, which the syntax for that is just token type dot bang. So just let me fix this import real quick. and pause here real quick. What this really does is just checks what is after the expression. So as you can see here, like int dot first. So the postfix expression is whatever is after the expression. So in here it is the exclamation point. So we're checking if this operator after the expression is of the token type bang. And if that is the case, then we will call the onLintFound method, and we will do report lint4, which we have specified in the other file, and we will pass the node and path. So as you see, this is very simple, but we have set up already a rule and created the message and the run method for that. And now that we have the rule set up, there is one more thing that we need to do. And that is in the library, we will have to go over the visitor file that we went over, where we pass all of these parameters that we use, and specify which override we want to apply this rule for. So this specifies the context in which we want the rule to run. In this case, we have override visit expression. And so we can run this rule every time the visitor goes through a normal expression. So in here, what we will need to do is just pass the list. And in here, we can call our rule we just created with all the parameters passed. And let me just see here. This will be the list. And since we only have one rule, we can already call the for each method and run lint. So there we go. We fixed the syntax here. And let's see the error here. Import the library. So now in the visitor class, we know that every time the visitor visits an expression, we will be running this rule that we just created. And if you want to create more rules, what you do is just simply extend this list here and add more rules as you go. And it will run for each rule. So let's have a look at the sample project that we have set up. As you see here, I have a very simple file that uses force unwrapping. And you can see here that we are already seeing an error. So this is the message that we have customized, and you will see force unwrapping should be avoided if possible. And you can see it is red. Okay, so that was the first approach. Let's dive into the second approach, which we will write custom lint rules, but we will use the custom lint package specifically. And luckily for us, because the custom lint package is built on top of the analyzer, a lot of this boilerplate setup we did in the first approach won't be needed. So let's go over the main differences. So in the setup, in the dependencies, we will add the custom lint as well as a dependency in the custom lint builder. And similarly to how we created an abstract class for lint rule in the first approach, I will also be creating an abstract class to help writing the rules in this approach as well. So what we have here is just an abstract class that extends Dart lint rule. And in this class, we have a run lint method and an override run method. So in the run lint method, you see here, this is the method that all subclasses should override, and this is where the logic of the linter is added. And this is the run method, which is mainly responsible for deciding if the lint rule is on or off for a certain file. And what I mean by that is that it just checks the analysis options provided for that and checks if it should be excluded. And then if not, it runs the lint and passes the resolver and reporter context. So what we run in this if statement here is simply this run lint function. So if there are no override methods to specify the context of running the rule, how can we run the rule in specific scopes in this approach? So if you remember, in the previous approach, in the visitor file, there are multiple override methods to specify the context that we want in each rule. However, this is not the case in this approach. So instead, what we use are hooks. Now, hooks are have a similar idea and allow us to run certain rules in specific contexts. And the hooks are registered in the run lint method using the custom lint context. Now, after you register your hook, you can specify the custom logic that you want to run whenever this hook is used. And if it is, then you can report the error. Now, there's similarly to all the overrides, there's also a lot of examples and use cases for different hooks. This can be something more general, such as visiting a node or visiting a class declaration. So let's dive into the second approach. If you see here, I have a different linter with all the setup that I've discussed and another sample package. The only thing different about this is that in the PubSpec YAML, we will provide our custom linter, but the path will be for this second approach, custom linter. So let's dive into the second approach. This will, luckily for us, will be much more simple. So in the library, we will have a rules folder where we can also see the abstract class we just went over and created. So whatever rule we create now, we'll have to extend it. So for sake of simplicity, I will add the same rule. So let's create a new file here. Avoid force unwrapping. And in this file, we will just create another class, similarly to what we did before. One thing you will notice is that it's actually not that much different when you write the rules. The main difference is in the setup. So here, this class, we will have to, again, extend our base lint rule. And in here, we will pass the constructor and call super, passing the code. And this will be the code or message that we set up. Let me define this now. So this can be just a static, constant code. And that will be of type lint code. So this is, setup is provided by the custom lint package. So this lint code, let's import that real quick. And in here, what we will have is a name, which is the name of our rule. So it can be the same as our file, avoid force unwrapping. And we will have the problem message. So the problem message is, again, is what displayed when we get the error. So it can be really anything. Don't do that. Oh. Hopefully something more informative. And let's finally close this. There we go. So now we have the code set up, which is of type lint code, with the name of the rule and the problem message. Now let's create our override. So let's do that. We have one missing override. And you can see we pass the resolver, reporter, and the context. And now how we register the hook we want to create is through the context. So we go through the context, just the analysis context, and go through the registry. And if you see here, these are all the options for the different hooks you can use. So it can be something like add annotation or, assert a statement. So really this resembles in the previous approach, all the override methods in the visitor class. So for this rule, avoid force unwrapping, we want to run this hook whenever we have an expression. So if we had add expression, we will pass the listener. Let's call this the node. And I think here they pass one more. There we go. There we go. And then we can add the logic in here. So if the node, this will be very similar to the previous one, is post takes expression and the node operator token type is a token type bang. Then we will report the error. So let me just fix this import real quick. And if this check is true, then we will go through the reporter and call the report error for token method. Now you might see a little cross here, and that's just because in this current version it's deprecated, but you will see that it will still work. So node.operator. So this is just an info warning about the method we're using. But as you see now, our rule is complete. And what we will have to do now is create another file for the plugin. And that will be creating our base to add all the rules we want to run. So in this library folder, I will just create a new file and call that the name of our plugin, so Lint. And what we have to do now is create a plugin base and call the create plugin method. And here this can be a private class, just any name really. So for this case, because it's Lint, I will just be expanding this, so it will be inside business Lint. And we will have to create this class. So let's quickly do that. So now we have a class of our plugin, and this will be extending the plugin base. So after that, we will create a missing override to get all the lint rules. And in this override, what we do is simply add all the rules that we want to run using the custom linter. So as you see here, we will just have to return a list. And in this list, we will specify any rules we want to run. So we have created avoid force unwrapping as a rules. So let us save that. And now the setup is complete. As you see, we have just a simple list. You can expand this as you create more rules. But now if we have a look at our sample package into our test file, you can see this is since there's another linter being used, this is a second message being displayed. But if you hover over this, you will still see the let me just run the custom linter just to refresh it. So you can run .run custom lint. So now if we look at our sample package and go to the file that we created to test the rule, we can see that this is also being displayed here with the name of the rule. So don't do that. And one thing that you can also do is run this through the command line. So we can just call .run custom lint, and then you will have a preview of all the errors found. You can also do the same, run it through the command line for the first approach, and you just write Dart run and the name of your custom linter. So this concludes how we can write custom lint rules for both approaches. So just a bit of a analysis of both approaches, and what I have learned from my experience and noticed is that, as you can tell, using the analyzer package, it's a much more complex setup process. And although this is more work initially, this does allow for more granular control later on. And also a great benefit of using the analyzer package is that you just get to use fewer dependencies. And that is important for some teams to use less third-party dependencies. So if that is something that is a priority of yours, then I think the analyzer package is more suitable. However, if you want something with an easier setup process and also not that much control over the different hooks you can use, then I think the custom lint package is very suitable for that. You will have to add the custom lint package as an additional dependency as well for that. And one thing I noticed in the custom lint package approach, as you add more and more rules, the performance for the custom lint package is much slower. So I do think another pro of using the analyzer package is just the performance of the plugin running and how much time it takes to analyze your code base. So thank you so much for listening. I've attached also some helpful resources and tutorials. So if you scan the code, you can see some documentation about how we can use the Dart Analyzer package and also how to use the custom lint package. Thank you so much.
All right, thank you, Natalie. It was like really good that we are going into cleaner and more structured code. And Maureen, would you like to announce our next? Actually, we got Natalie onboarded for our, of course, live Q&A. If you got questions from earlier, drop them in the chat. But welcome, Natalie. By the way, you're muted.
Hi, thank you.
So we can actually, if you want, we can directly start with the questions.
Yeah, sure.
Sure. So here is our first one. How can the plugin be integrated into a CI/CD pipeline?
Yeah, really good questions. At the end of the day, this is all about making the quality checks seamless. And in order to do that, I think it's easiest to integrate it into the pipeline. So in order to do that, it's quite easy. You really just have to, depending on your CI/CD tool, whether you use Jenkins, GitHub Actions, regardless of what you use, you will need to just add a lint job in your pipeline configuration file. And in this lint job, I think it's important to just have a step that just runs your custom linter. So you can do that easily by adding a step that uses Dart run and then your custom linter. And another tip I would say for that is that to ensure to have another step in that job to make sure that the dependencies are actually updated. So with that, you can use the Dart pubget command.
Totally, you would just like put it to your GitHub Actions, Bitrise, GitLab CI.
Yeah, and that way you can just automate the checks, and every time your pipeline runs, you can have, see if you have any errors without having to run the command directly each time.
Meantime, I'm going for the next question. You got really crazy good comments. Comments were like going crazy. I will show them just later on. Here is our next question. What are some examples of other plugins you can create with the analyzer package?
So really it's up to your project-specific needs. The way that I like to think about it is that whatever plugin you will create using it, you will just extend the analyzer package capabilities. So that comes with anything revolving static code analysis, really. And I think one really interesting thing that you can do is look into code duplications, for example, or unused codes. So you can really extend the capabilities of the analyzer package and create your own plugin to just check if, even if you have unused API calls or unused sections of the code, it really helps with the code maintainability as well. So I think the limits are, quite high.
Totally. Like I got immediately in mind, like maybe disallowing print things that you can have, enforcing naming rules, pretty much stuff around.
Also for documentation, it can be really helpful, really ensuring that there's a set standard for documentation so that maintainability down the line won't be too difficult.
Meantime, I'm gonna pull the third question. Maureen, maybe you can guide us in that while I'm checking the comments for her.
Yeah, sure. So the next question is, are there any performance considerations when using custom lint rule extensively? What's your thoughts on that?
Yeah, as I mentioned a bit in the analysis slide, after you add a lot of rules, using the custom lint package, the performance does slow down a bit, especially on how complex the logic for your rule is. So the more complex logic you have, and if you have a lot of custom lint rules, then I do think that you need to take the performance, and especially the time running to analyze your code base if you have a large code base. So mainly just the time for the command to run.
Okay. Great insights.
Actually, I saw Maureen. You asked a question. Maybe you can mention it here.
Yeah. So it's a great talk, and adding lint rules is really good in our projects. But I was kind of curious, what's your take on using the Flutter DCM rules instead of your package?
Yeah, I think the Flutter DCM rules, the Dart code metrics, right? They are really helpful for, I would say, general purpose linting. And even though they are configurable to some extent, I think there is certain limitations to what you can add, really. So if you really have more specific project-specific needs, it would be more helpful to use a custom linter. And really, maybe I can share a really brief example of how I even came around to getting this topic, is that we realized in our code base we had not necessarily errors, but in some of our serializers, we were using some types that are nullable and some that are not in the serializer. So something just specific to check the serializable nullable type, something like that. It's more catered to your needs, and something like a custom linter would be more handy for that.
Yeah,
Thank you.
interesting. I agree with that.
Maybe if you can, I do remember, I think it was last year in Stockholm, one of our dear Flutteristas, Daria, was giving a talk in Flutter and Friends. I think she was also extended on that front. Maybe we can have a look if she is in the comments somewhere. We can see. Actually, it would be great to like get both of your takes there. Meantime, thank you for being here all the time, and I would like to show out a little bit all the comments coming to you and Alba. Speech learning a lot, super interesting subject. I was actually able to show them to you. It was really great presentation. Thank you really for this. We got really great ways of showing how to structure your code, how to make it cleaner, how to make it like better.
Thank you so much. I really appreciate being here, and thank you as well for inspiring all the speakers.
Thank you so much.